All right, on the board. Now, number one. Number one, we just have to add the 4 over and then divide by 2. So we get then, what does that say? X equals -4?
Yeah, he's right.
I'll buy that one.
Wait,
Okay.
what?
Yep, you add the 4 over, you get -8 on the right. Divide both sides by 2. X is going to be -4. All right, number 2, we distribute, so we get 4x plus 8 equals 10. Subtract the 8 over, get 2. Divide both sides. So we have x equals 1/2. I'll buy that one. All right, number 3, we distribute the left side. So we get 2x minus 4, I agree, equals 4x plus 6. Got to get your x's together, so he subtracted this 2x over to the right. Got -4 equals 2x plus 6, good. X by itself, so subtract the 6 over, get -10 on the left side. Divide both sides, and x equals -5. I buy that one. And then, now the last one. How many of you guys struggled maybe a little bit with that one?
Not really.
Not really? I mean, I was kind of hoping you would, because let's face it, I said solve for the variable, right?
No,
Did I say which variable?
no, but I saw for one.
No.
I meant to solve for.
What if I said solve for all variables?
Well, you need to say wait, but do it twice.
You could do it twice, but you don't get, you get x equals, what's this say, -12 plus 4y over 2. All right, you could do that. So that would be x equals -6 plus 2y, right? And then you could solve for y. Now, wouldn't you rather, though, get to a point where you get x equals maybe like 3 and y equals 4 or something like that?
I was right on number 4. I was right.
Okay, that's a problem, though. We don't have enough information right now, do we, to find what x is equal to, what y is equal to. All right, we don't. All right, that's the big problem for us, is we just don't have enough information to be able to get both those variables. That's what this chapter is going to be about. So today, starting chapter 6, systems of equations and inequalities. All right, so get your notes out, ready to roll. Got the new stuff going, new stuff coming at you. Now, this chapter, I'll come back to it here in a second. So, systems of equations and inequalities. First one we're going to do is solving systems by graphing. So what you're going to find, if you want to find two variables, you need two equations, okay? Two variables, you have to have two equations. Otherwise, you just kind of guess and check, okay? I'm going to give you 3 different methods that you can use to solve for systems of equations, okay? 2 equations, 2 variables, there'll be 3 ways to solve for your x and y terms. First one is going to be graphing, then we're going to do something called substitution, then we're going to do something called elimination. All right, we're going to hit each one of the 3. At the beginning, I'll say to you, yes, solve this problem by graphing. Then like the next one might say solve by substitution. Next one might say solve by elimination. Okay? And then I'm going to give you a choice on some problems. And I'm going to give you some tricks along the way to know maybe which method is the easiest for that particular problem. All right? And then after we hit a certain point, maybe as we get through towards the end of this chapter, I'm just going to say solve it. And I won't really care which way you solve it. Does that make sense? You'll see as we go forward, graphing is going to be used a little bit less, probably. Substitution, elimination, we use a little bit more. This one here is nice when you get the problems with a lot of word problems, especially when you have graphs. And the other ones will be used more just straight algebraic problems. All right, so what is a system of equations? A system of equations is a set of 2 or more equations that have the same solution. The solution of the system is any ordered pair that satisfies all equations in the system. So you see here, This could be 2 or more. For you guys right now, you're going to have 2 equations with 2 variables. When you hit algebra 2, then you'll do 3 equations with 3 variables. One of the big keys I'm going to tell you guys for this chapter is when you're solving systems, you have to be neat. On your paper, you need to be neat. If you're not neat, then you're going to mess stuff up. You're going to get wrong answers. And you're going to be frustrated because you don't know what's going on. Okay? You have to be neat with these. And then, like I said, then a solution is any ordered pair that satisfies all equations in the system. Now, ordered pair, remember, our most common ordered pair is an XY point. All right? X comes first, Y comes second. And that's how we can write our final answers here as well. All right, we good? Okay. All right, so to solve by graphing, I don't even have it. All right, basically, so just listen to it. To solve by graphing, you graph 2 lines on the same, it should say on the same plane. I'll fix that right now. All right, so you graph them on the same plane, or same coordinate plane. Now, when you graph 2 lines on the same plane, you have 3 possible outcomes. 1, they cross. 2, they lay on top of each other. Or 3, they don't touch. Okay? That's your 3 possible things that could happen. If they cross, they intersect at 1 point and only 1 point. If they lay on top of each other, then every single point is exactly the same. Therefore, I'm going to have infinite solutions. If they don't touch anywhere, it's because they're parallel. And if they're parallel, there's no solution. Okay? The intersection of these points is going to be the answer for your solution, your system of solutions. Okay, so say that again. The place where they touch is going to be your answer. That's going to be your x value. That's going to be your y value. All right. I write down intersect at 1 point is one solution of each other's infinite, and don't touch is your parallel lines is their solution. Now remember with these 2 guys, for something to be parallel and to not intersect, their slopes have to be the what? Slopes have to be the same, correct. Now, if the slopes aren't the same, they're not going to be parallel, so you should know right off the bat whether they're going to touch or not. All right? And keep in mind, graphs go on forever. So just because they don't cross, below 5 or something like that, you got to keep going. All right? You can't just stop and say, oh, it's no solution because they're not touching in the first 3 or 4 points. It's not the case. All right, you have to draw it out until they touch, and you'll be able to know right off the bat, like I said, they have the same slope. Yeah, then there's no solution. If they don't have the same slope, then they're going to touch eventually. These lines are infinite. I meant to get that down. Dive in. All right. So those are your three possible outcomes. I'm going to tell you that first one's probably 90% of the time this one's going to happen. Okay. This guy's probably 5%, and this guy's probably 5%. All right. So the most common is going to be obviously intersect at one point, and that's your solution. Okay. So let's look at this and see what one looks like. So I have two lines here. I have two separate problems. We're looking at the first one, the one in the white. Y equals 2x plus 4, y equals x plus 2. All right, it's written in the form that we're ready to graph. I can graph this guy, I can graph this guy. If I could solve these guys, I could solve them both for x, but again, I'm going to get something like this. Y equals 2x plus 4. Well, then I could get x equals 1 half y minus 2. Okay? That doesn't do much for me. But when I do both equations at once, let's graph these and see what happens. So the first one, y equals 2x plus 4. I'm going to start at 4. Start right there. So my y-intercept of 4, then my slope is going to be 2. Up 2 over 1. Now when I do this, I'm going to add a few more points on here on my same slope just to make it a little more accurate. All right, so there's my first line. All right. Now, second one, y equals x plus 2. So I go up here. Hold on. Why did I start at -1? X plus 2, right here. Okay, up 1 over 1. And I'm going to continue on. Now I'm looking at this, and this is going to intersect somewhere to the left, isn't it? All right, so I really don't need to go any further to the right. Now I can come over here, though. There, there. And I'm just going with the same slope the whole way across. Do those lines intersect? Yes, they intersect right there, don't they? Now what's that point? -2 what? That's my x. What's my y value? It's a point, yeah. -2, 0. Okay? -2, 0 is that point. All right, what's that mean for us? Well, let's plug this in here once. Check it. Make sure that works. Is that a solution for both of these guys? So, -2 is my x value, 0 is my y value. So I'm going to plug in the first equation. 0 equals 2 times -2 plus 4. 2 times -2 is -4, plus 4 is going to be 0. Is both sides equal? Yes, so it works in that one. Second one, y is going to be 0 equals x, which is -2 plus 2. -2 plus 2 is going to be 0. So 0 equals 0. That one will work as well. That makes sense? Yes.
Does it matter what value you put in each equation? Or you just,
I put in what I found.
Yeah, you put so. Oh.
This was my check.
That's not.
Okay. I graphed it over here. When I graphed it, that gave me the answer. And then I plugged that answer back in to check it for both equations. Nope, same exact ones. Does that make sense how we did that? All right, where they cross at, where they intersect, that x value is my x value. That y value is my y value. Okay? Look at the next one. So the next guy I have 2x minus 1 and 4x minus 7. So, first one, 2x minus 1. So I start at negative 1, and then up 2 over 1. Up 2 over 1. And I'm just going to carry this on for a little bit. Okay, and then down 2 over 1, down 2 over 1, and so on. We'll go with that, and we'll see if we need to go any further. Okay, second line, 4x minus 7. So I'm at negative 7 is where I start at. My slope is 4 over 1. So how do I graph that? Up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. Still didn't quite hit it, did we? All right. Up 4, 1, 2, 3, 4 over 1. Do we count those right? 1, 2, 3, 4. Now we should be right here. It's 5. 1, 2, 3, 4, 1. There we go. See what I mean about having to be neat? All right, if you're not neat with your points, you're going to have them intersect at weird places. All right, so this intersects right here, right? What's that point value? What is it? Say it. 3, 5. Okay? So I got an answer of 3, 5. X is 3, y is 5. Let's check it. First one, y is 5. 5 equals 2 times 3 minus 1. 2 times 3 is 6 minus 1 is 5. So that one's good. Second one, I have 5 equals 4 times 3 minus 7. 4 times 3 is what? 12. 12 minus 7 is 5. Is that one good? Yep. So that would be my answer, 3 and 5. Questions? Yeah.
Well, if they do intersect, will they always be on a whole number, or will it do it to, like, or they be in the middle, do it to guess me?
For us right now, they're pretty much always going to be on whole numbers. All right.
Whenever we take the test, will theirs be?
Yeah, for the purpose of this course, yeah, I'm going to give you whole numbers. All right. And, just in general, no, they could cross anywhere. Okay. Now, something you can always do to check. Let me pull something up here. If I pull up Desmos, you guys ever been on Desmos much? Just whatever we did in here, huh? All right, if you click on Desmos, you go to the graphing calculator. Okay, so the one we just did was this guy. I'm going to write it down. Y equals 2x minus 1. Y equals 4x minus 7. Okay, so maybe it's not working out very well for you, or you're having a rough time. If you go to Desmos here, type it in. Y equals 2x minus 1. Y equals 4x minus 7. Okay, so there I have my two lines. Now if you come over here and click on this, they obviously intersect here, right? Just click on one of these lines once. Right click. All right, it highlights that point for you. 0.035. Okay, so you can use that to check. Make sense? All right, we are going to do them by hand. All right, to start with here. Then we'll use some Desmos too to do some ones with maybe bigger numbers and that type of stuff.
Are we gonna be able to use Desmos on the test?
On the test, you're going to have probably two of these that say do them by hand. Right now, this would be a way to check yourself, at least this first lesson. Make sure you're doing it right. Okay?
Do you think we'll take the test this working period?
It'll be close. Be real close. All right. So I just want to show you Desmos. So I'm going to give you a problem here, and I want you guys to try it. ahead, draw a graph on your paper. Do that first. Give everybody a piece of this. That'll help you get started there.
I like your bright yellow sweatshirt, JP. It looks like mustard. I like mustard. Mustard. What'd you eat for Christmas, John?
Money.
Really?
Yeah, then it's on a new dirt bike and I have to pay for it.
All right. I'm going to give you. First one is y equals negative 3x minus 3, and y equals 2x plus 2. Okay? These are two equations. Graph them both on the same one, and see where they cross at. Give you a couple minutes to try that one.
Anyone here ever had the Monster Energy coffee?
So I graphed the first one, negative 3x minus 3. So I'm at minus 3, and I have a slope of negative 3. Down 3 over 1. Down 3 over 1. Now, it's probably not going to help me much. I need to go to the left as well. Okay? So I went down 3 to the right 1. So now I can go up 3. 1, 2, 3 to the left 1. Up 3 to the left 1. And again, if you're doing this and it doesn't make a straight line, you did it wrong then, right? Okay, so I'm going to stop there. I think that'll probably be enough for me on this one. So that one works. Second one, y equals 2x plus 2. So I'm at positive 2. My slope is 2. Up 2 over 1. Up 2 over 1. Now, obviously, if I keep going right, that's not really going to cross, is it? So let's go back here and just do it opposite now. Down 2, left 1. Down 2, left 1. Now I'm in good shape because they intersect. They intersect at one point. Yep, what's my point?
1, 0.
Good, negative 1, 0. All right, that's where they intersect at. If you plug it in and check it, does it come out right? As long as you math right. Right, Hoover? All right, looks good. Questions on that one? All right, let's do one more. Erase this. All right, second one for you guys to try is let's go with this guy. Y equals 1/3 x plus 1, and y equals negative 3x. Oh, actually, no, I don't like that one. Let's try again. So that one's going to be way off your screen. It's not very efficient. I changed my mind. Sorry. As far as your line go, it's a 6 or 5? 5. All right. One additional one's not going to kill you. So let's go y equals negative 1/2 x plus 2, and y equals 1/2 x plus 6. Try that guy. All right. All right, so looking at this one, y equals negative 1/2 x plus 2, and y equals 1/2 x plus 6. First guy, start graphing him. We're at positive 2. We are down 1 over 2, down 1 over 2. Now I'm pretty sure I have to go left with this one, don't I? So let's go left 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1. There's the first line. Okay, that looks like that. That's the first line. Second line, y equals 1/2 x plus 6. So I'm at plus 6. 1/2 is up 1 over 2. Now, going to the right any farther is not going to help me, is it? Okay, so let's go down 1, left 2, down 1, left 2, down 1, left 2. So we crossed really nicely at a point. Boom, right here. All right, what's that point? Good, negative 4, 4 is that point. Bingo. Negative 4, 4. Where they cross, you plug it in, check it, you're going to come out just fine, right? Questions on that? How many of you guys got negative 4, 4? Okay, this one here, this is just one of those ones, it's practice. Practice graphing, okay? If you had trouble graphing when we did it first chapter 3, you might have a little issue.
Isn't there a second way to do this?
There's 3 ways.
Are they easier than us? Really?
Yes and no.
Okay, I'm probably just gonna do it this way.
So what you're going to find, there's very specific types. Okay? This style here, where you have y equals and y equals with smaller numbers, solved by graphing is pretty easy. Okay? Now, in the homework and stuff, you might get something that looks like this, too. 2x plus y equals 10. Can I graph that guy right away? No, what I have to do is solve for y. I take 2x over, and y is going to be negative 2x plus 10.
Oh, yeah.
Now I can graph this guy, right? So let's look at a couple problems then that maybe are a little bigger. Remember what I said? If you have bigger numbers, then maybe you want to use the Desmos thing.
Oh, yeah.
Okay. And yeah, this one here, this will work for now. The next 2 ones, they're going to be a little bit longer process. They're going to look a little bit longer, but they're kind of going to work for all of them. If I put a number 123 in here, I don't really want to graph out to 120. You know what I mean? All right, so like I said, you'll find as we go, there'll be ones that are a little different. So let's look at these ones. Solid system equation by graphing. And like I said, we're going to use Desmos for this one because the numbers are so big. All right. In your assignment, I'll put maybe 1 to 10 do by hand. These 2 you can use Desmos or something like that. All right. So on this one, first one says one satellite radio charges $10 per month plus an activation fee of $20. Second service charges $11 per month plus an activation fee of $15. What month was the cost of the service the same? So looking at this guy, we got to rate the equations first, don't we? All right, so let's look at service 1. Boom. And I'm just going to say y equals and y equals. We say that y is the total cost that you pay.
Oh, I know.
So look at the first one, $10 per month plus an activation fee of 20. 10 and 20, which one's my slope? 10. Okay, that's my slope, 10x. $10 per month. And then is there anything additional? Plus 20, perfect. Second one, what's the equation going to be for it?
Oh, I know. 11x plus.
11x plus 15. Correct. All right, 11 per, so that would be my slope. Now, looking at that one, do we really want to graph 10x plus 20, 11x plus 15? No, I don't want to. So let's go ahead and write this down here, because otherwise I'll forget the other screen. 10x plus 20. Y equals 11x plus 15. Now this is where it's going to be nice to use something like Desmos. So let's pull up Desmos. All right, all you have to do is type in Desmos. First thing that comes up, click on the graphing calculator. We did this. You guys made your pictures. That's right.
Yeah, I lost 10 lines.
So y equals 10x plus 20. And then y equals 11x plus 15. All right. So if you look at this, they're going up pretty far till they cross, don't they? All right. So let's keep going. I'm going to click on one of the lines. So then it'll show me a dot right where they intersect at. So not yet, not yet, not yet. Where'd it go? There we go. There's the dot. That's where they cross at. Cross at 570. All right, so what does that mean? 570. X value is 5, y value is 70. Well, if we look back at our equations, our y value is how much it costs. X value is how many months, right? So this says after 5 months, you both paid 70 bucks. Make sense? Yeah. Right? After 5 months, you both paid $70. Now, here's a bonus question. If after 5 months, you're paying the same no matter which one you choose, which one's cheaper after 5 months? Top one, right? Because if 5 months costs you 70 bucks, according to this one, 6 months would cost you 80 bucks, right? Another 10 bucks. This one here would cost you $81. See the difference there? Okay, that means those two lines, when after 5 months you both paid 70 bucks no matter which plan you had, then you can make some inferences after that. All right, let's look at one more. So last one. Number of right-handed students in a mathematics class is 9 times the number of left-handed students. Total number of students in the class is 30. How many right-handed students are in the class? How many left-handed students are in the class? This one's a little trickier because it doesn't have stuff like per and those types of things, does it? So let's say right-handers are X and lefties are Y. You all right with that? So first one, it says right-handed is 9 times the number of left-handed, right? So if I have my right-handed, what do I have to do to the other one? Yeah. What's the equation? Okay. X equals be 9 times Y, right? So I have to multiply my Y times 9 to make it be equal. Now the second one, it says the total number of students in the class is 30. Well, that just means my righties plus my lefties is going to be equal to 30. Agreed? Now, to graph these guys, we have to solve them both for y, don't we? So this guy here, let's just divide both sides by 9. So I have y equals 1 over 9x. Second one, I'm going to subtract the x over. So I have y equals negative x plus 30. Okay, there's my two equations now. Do I really want to graph those? Not really. 1 9x and y equals negative x plus 30. How do you get what? Hold on. Let's graph it first.
I want to answer it.
Okay, so 1/9 x. The next one, y equals negative x plus 30. Boom. Got to zoom out a little bit here. They cross one time, yes. What's your answer?
There's 27 righties, 3 lefties.
Alright.
Now, hold it.
Zoom in here. Check it. So x was 27, y value is 3. So we got 27 and 3. 27 is the number of right-handers, 3 is the number of left-handers.
I actually just took 30 times 0.9, got 27, and then the 3 left over were on all lefties.
So really what you did was substitution,
Yeah.
which is what we're doing tomorrow or Thursday. So, but that was how you would solve that guy by graphing. That makes sense? Any questions?